In this video, we'll discuss what it means to complete the square. So let us consider an algebraic expression of x squared plus 6x. And what we want to do is figure out what do I need to add to this expression to create a perfect square. So suppose I draw a rectangle and the area of this rectangle is x squared plus 6x. That means that we can have the width as x and the length as x plus 6. Because if we have x times x plus 6, that will lead to the area of x squared plus 6x. And what we have done to find these lengths is take out the greatest common factor in x squared plus 6x. And that factor is x. So now we have a rectangle with that area. Now suppose that I take the length, which is x plus 6, and I divide it into two sections, which is x and 6. Notice then that I still have the area of x squared plus 6, because the area of the square would be x times x, which is x squared. And the area of the smaller rectangle that we have created would be x times 6, which is 6x. So the total area is still x squared plus 6x. And all that we have done is we have created a square and a smaller rectangle within our big rectangle. Now, let us take the smaller rectangle and divide it into two rectangles again. So I take the 6 and I divide it into 2, so that will be 3 and 3. So now the total area of the rectangle would still be x squared plus 3x plus 3x, which is in total x squared plus 6x. So we have not made any changes to the area of the rectangle at all. We have simply rewritten the length into x plus 3 plus 3. And remember, our aim is to find what do we need to add to this expression to create a perfect square. So I want to create a square out of this rectangle. So let us take the second small rectangle of 3x and move it to the bottom of the diagram. This is the diagram that we have after we have shifted the smaller rectangle to the bottom of the diagram. Notice that we still have the total area as x squared plus 6x, because the area of the square is x times x, and that is x squared. The area of our smaller rectangle is 3 times x, that is 3x, and the smaller rectangle at the bottom is also x times 3, which is 3x. Now, in order for us to create a perfect square, we need to complete this diagram by adding a little section here at the bottom right. Now, the dimensions of that square is 3, which is the 3 we have at the top, and 3, which is the 3 we have on the left-hand side. So in order to create a perfect square in this diagram, I need to add an area of 3 times 3, which is 9. Then we have a perfect square with the area of x squared plus 6x plus 9. Or we can say the area is x plus 3 squared, because the length at the top of the square is x plus 3, and also the length of the left-hand side is also x plus 3. So the total area is x plus 3 times x plus 3, which is x plus 3 squared. So that is what it means when we complete the square. We simply take an algebraic expression and rewrite it in such a manner that we can create a trinomial that factorizes into a perfect square.